For question D, we can pretty much eliminate greatest common monomials, difference of squares, square binomial, binomial pair of factors. We're really left with just factoring by grouping. So this one is going to be a little tricky. Or is it? It could look like this trinomial should be grouped together. But if I were to group this together, I would end up with x squared minus 5x plus 3. And I know that can't be factored further. So I know that that is not going to make sense. So perhaps I should group them there. Because they both, what factor do both of these terms share?
X squared.
X squared. So this will be x squared times x minus 5. If I group these together, will I also get an x minus 5? Yeah, I do. What do both of these share? 3. Oh. And we get x minus 5. Perfect. What is the answer? What is my answer? Allie?
A quantity of x squared plus 3, and then a quantity of x minus 5.
And you need to be careful. You do, since you have this squared, is it possible to factor that? The only way to factor that would be as a difference of squares, and I know 3 is not a perfect square, so I'm pretty much stuck with that. All right. So then, this is the only really funky one. And you notice that it's funky because y minus 5 and 5 minus y are not the same thing, and I can't flip-flop it. Yes, Joe?
But they are the same thing, because it's negative y minus y. So it's just adding, you just multiply everything by negative 1, so you get negative y plus y.
So if I multiply this whole piece by negative 1, it'll work. OK, so I'm going to multiply this piece by negative 1. So negative 1 that's on the outside times negative 1 is positive 1. Excellent. 5 times negative 1 is? Negative 5. Negative y times negative 1 is? And then we just have our other binomial. Joe, incidentally, you are the first student ever to just spontaneously figure it out that I've ever had. Way to go, Joe. So then, what is the final answer for this problem? Joe, you might as well finish it up. And that's it.